Hey, it's Norm from Tested, and I am here surrounded by BattleBots. That's right, the show's coming back. It's gonna be on ABC, premiering June 21st, and I have the opportunity to chat with some of the builders and check out the robots. They've come from all over the world to combat. Let's go check them out. So this is John and Dave of Team Robo Challenge. You guys made a big trip here to represent. Tell me about your robot.
So this is Beta.
Beta, not Beta.
Sorry, Beta.
Beta. Okay. What's the design? What's your primary weapon?
So it's all about this big electric motor in the middle.
Okay.
This connects to a gearbox and these chain drive to this huge hammer.
And that fires that right over.
That is a massive hammer.
You want to grab the end of that and feel the weight of it?
All the way down.
Oh, wow, and it stops right there.
So it gets from here to there in quarter of a second.
Quarter of a second.
Yeah.
And ideally, your opponent is right in front.
Yeah.
Ideally.
Have you tested the strength of this?
Not yet.
We have in the past, but we've made some changes. We haven't tested the changes yet.
Okay.
So we're about to go out in a few minutes and do a first test.
And what do you anticipate the damage of this beam will do? What could you
think
break?
We're going to get in trouble because last time we were here, we damaged the floor. So it jumped up in the air and slammed back on the floor and made massive, bowl-shaped dents in the floor from that. So,
Well, hopefully there'll be an opponent underneath here.
Yeah.
And how long does it take to reload once you've deployed?
Reload again is half a second or so. Hopefully we can use it to self-right as well. If we get flipped over, we fire it and let's get back on our feet.
Now, because your robot's single-facing, you're going to always want to be facing your opponent.
Yeah.
Can you talk about the armor design?
So the armour itself's made from the same material they make tanks from. So it's like a wear plate steel and it's all bent out of one piece with just the one weld right in the middle at the front. So hopefully that should take most of the damage. And on top we've got this Lexan, so that's like a bulletproof plastic. So that should take a lot of the damage away from there.
I can't wait to see this tested and to see you guys in the ring. Thank you so much.
Thank you.
Thank you.
This is Paul with Aptix Designs. You and your team have built Bite Force. Tell me about Bite Force.
Bite Force is a grabber robot that has these giant jaws, basically. So there's the lower lifting jaws that can go 180 degrees over.
Okay.
There's the upper clamping jaw. So we got a linear actuator for the clamping jaw, and then a 3 horsepower motor for the lifting jaw. A lot of robots in the past used tank treads, but they didn't really do them right, and people don't use them very often now. I figured do a little different. Tank treads look cool. Also, our tank treads have magnets in them for extra downforce because the arena floor is steel. So we want to have extra traction by having extra actual downforce.
And that's a really important part of keeping the robot in play is making sure you have a lot of downforce so you're not being lifted up.
Sure, there's a set weight class so everyone weighs the same.
Right.
So if you can do something to effectively pretend your robot weighs more, it's going to not get knocked around the arena as often. When I go to flip someone over, I'll hopefully be more held down to the floor so not flip over myself. When you fight a spinning robot, you're not going to get knocked away as much, you'll be able to aim the wedge at them and defend against them.
Because you're on tread design, how maneuverable is your robot and how fast can it go?
The robot's very maneuverable because we do a couple of little tweaks. So in the very bottom center of the tread, we push a little slider bed down about 1/16 of an inch. So effectively the robot rocks a very unnoticeable amount, but according to the robot, it's really riding on 2 wheels basically in the middle. So this is one configuration of the robot.
Yeah.
Part of making a successful design is having multiple configurations.
Okay.
So behind you we have sort of these steel mini wedges, we call them wedgelets, that go in front of the robot, and they ride on the ground to get underneath their opponents. We also have a large defensive steel plow that goes in the back of the robot. So for facing big spinning weapons, basically we have a bunch of angled steel wedges, and we pull off the upper jaw. So we still have the flipping forks, but the robot's light enough that we're able to put this massive steel part in the back. We also remove those wedgelets in the front of the robot.
Well, your base configuration is with the grabber that can go in the front or the back.
The front forks are our basic configuration to get under our opponents. Once you're underneath them, we can clamp them, push them around, do whatever we want with them.
Awesome. Well, thanks so much, guys.
Yeah.
Good luck.
Sure.
So I'm now joined by Zoe, who's team captain of the Machine Corps. Zoe, your team's robot is Chomp. It looks like a massive, impressive machine. Tell me about Chomp's functionality.
Chomp is mainly a biter. So this giant jaw that you can see is actually designed to apply 30 tons force down. We had to make a modification at the last minute. The motor that I wanted to use turned out not to work. this motor, which as you can see isn't on the robot.
It's not on the robot.
It's not on the robot. So there's a new motor, but I expect that it will still be able to crush with 10 tons of force.
That's a lot of force.
It's a lot of force, yeah.
So how fast can you get the pincher down?
Actually, the thing I'm working on now is a gear switcher. So I'm just using an off-the-shelf drill here.
Yep.
And most of those drills you buy on the shelf, they have a 1-speed and a 2-speed. In the second speed, I think it can close in about a second.
Okay.
However, that's the low torque speed.
Yeah.
So I think if we had to choose, we'll run in the slower speed so we can actually crash.
So what's your strategy of getting the opponent stuck in here with enough time so you can actually pinch down and get all that pressure?
The amount of time I've devoted to thinking about strategy is sadly really small. So hopefully that will develop.
Okay.
drive as well as possible. Try and get underneath them. Stay facing forwards. We've also got a flamethrower. That's the secondary weapon. We don't seem to be having success with the chomper. We may sort of roast and flame and sort of back up and go forward and sort of keep them in our ranged weapon.
Now,
radius.
is this can be piloted by one driver or two?
No, I will drive it, and then my friend Joe, who's actually socked out in the car sleeping because we've been working on this thing all night, most of the week, is going to drive the weapons.
Got it. So a lot of cooperation, and he'll be able to adjust for 2 speeds for this, hopefully. All right, well, good luck.
See. Thank you.
And we can't wait to see this in action.
Yeah,
Thanks
thank you so much.
All right, so I'm joined by Paul here. Paul, you and your team have an interesting robot. This is Witch Doctor, but you have more than one robot.
Yeah.
You also have Shaman.
Yes.
What's the strategy here? 2 robots in the ring on one side at the same time?
Yeah, really it's one large robot that is intended to do all the damage, and then a small robot that's really a harasser. It's much smaller, quicker, it has fire, so it does have some real appeal for the audience to watch it. Plus it's very small, so if it gets hit, it's much more vulnerable. The strategy for it is to kind of get around the side, get around the back of a robot, really prevent the other robot, the competitor, from doing what they want to do. Oh, you want to turn left, Witch Doctor's going around the left, we're going to prevent you from doing that so that Witch Doctor can then get to a vulnerable spot on you and really wreak damage on your unarmored rear
and all
side
the electronics.
object. Yeah.
Burn out the wires.
Yeah,
get to the
Witch Doctor
batteries.
is designed to go through a robot. We want this robot to physically rip off your outer armor and plow straight through you.
Wow, so talk about the design here. Your weapon's in the front. That's an incredibly heavy, looks like
It's about 60
spinner.
pounds, 16-inch throw. Wheels are all independent, so they're individual chain segments that if one wheel gets knocked off or anything, we won't lose drive on that side necessarily. We have a speed controller, really powerful speed controller, because we have a very large brushless motor inside of here, and that's just strictly for spinning the weapon.
I gotta imagine that you and your team have practiced both Witch Doctor and Shaman working together. Is Shaman going to be mostly sacrificial?
Will be sacrificed if needed. If it comes
needed.
down, if we're in a dire straits, we're in a desperate situation, Shaman is still able to move around, and Witch Doctor's vulnerable for a moment, and that split second will cause enough distraction for the other driver that Witch Doctor can then recover. Certainly, Shaman will be sacrificed.
It's a really interesting strategy. Can't wait to see this in the arena, fighting other robots. Thank you so much, Paul, and good luck.
Thank you. Take care.
This is a really interesting looking robot. Donald, your team built Lockjaw. Tell me about Lockjaw.
Well, so Lockjaw is kind of a design that I've evolved over the years. My premise is that a lot of robots try to build very destructive robots and put the weapons on them. I've always kind of went after the alligator, or the shark kind of approach, the grapple and drag you to your submission and kind of remove the ability for you to utilize your weapon. So the grapple mechanism that you see here is another variation. What it does is it has 2 separate jaws. Each one is on a 3 horsepower, 250 to 1 ratio high torque gearbox and a chain drive. It's got basically what I call a top jaw and a bottom jaw. And so we start off with the jaws not only being able to lift and grapple, but be able to arch ourselves backwards.
Oh.
And so instead of just trying to lift up, if you think about it, you're trying to lift the robot up, you have to have weight in the back.
Yes.
Or you can use other means. There are other tricks. But in this case, what I decided to do is actually arch the back backwards. And so the hope is maybe, I'll be able to get to the side of something and then arch the back of the robot up. And at this point, what will happen is the links have been worked out for the length of this robot and the jaw, and basically about the different variations of thickness of robots, and the hope is that the back end eventually just swings up underneath, and then I just fall back.
You can flip it.
I think what's going to happen is it's going to kind of end up like an otter, upside down with them in its mouth. That's the design intent, as we would call it. And so it has 2 flamethrowers here, which are kind of pointing down for that specific reason. Anything in its jaws get a little toasty, maybe.
So the idea is that if you could pull off that strategy,
Then
this
I'll
robot
feel-
flips around, literally in these jaws, and then you're going to shoot flame up into
I
it.
mean, that's where I was going with it.
All right, all right.
So that's my vision of what's cool and what would be worth doing on
You've
this
sold me
machine.
on the vision. I want to see it happen.
I want to see it happen too, and I will consider that a win. Even if I lose, those are the kind of things that sometimes as an engineer, you just want to see it do what you hoped it would do.
Thank you so much, Donald.
Yeah.
Good luck.
Very nice talking to you.
Thanks. One of the more unique robots in BattleBots is Ice Wave. Mark, you and your team have built, I think, the only combustion engine robot.
Yeah, I think we were the only internal combustion engine robot here.
So internal combustion
Yep,
engine.
exactly. You got
It's
it.
not because
Not
it's
many
cold,
people get that.
but because it's hot. That's actually running your weapon. So
Exactly.
explain your weapon.
Yeah, so the engine is a 15 horsepower gas engine from a fireman saw
Oh,
that
okay.
they use to rescue people out of cars.
Yeah.
So that powers this 4-foot long blade, and it spins at about 300 miles an hour at the tip.
So why did you choose internal combustion engine as
Because
opposed to electric?
it's really cool.
It's really
loud.
cool.
And the intimidation factor is there too, because when this thing fires up, it's just kind of like
It's loud.
really, yeah. It just the other competitors they come running, and it'll be exciting.
And it's going to rev up. How long does it take to get this revved up?
Well, we're in the process of switching it over and making it a little bit faster to spin up. We got about 5 seconds yesterday to top
Okay.
speed.
All
so
right.
we'd like that to be a little bit faster because there's some fast robots here.
So
yeah.
wedge, horizontal spinner, and a lot of armor up top. You got to need that armor, right?
Yeah, and by BattleBot standards, this armor is not very tough. It's about an 1/8 inch of aluminum, and it's welded together. So the structure itself is strong enough to probably withstand some of the arena hazards and things like that. But some of the other robots will. There's a lot of crusher robots here and grabbers and stuff that we probably have to worry about a little bit.
All right. Well, a lot of that will be sorted out in the arena.
Yeah.
Ice Wave, running on gas. Thanks a lot, guys.
Thanks.
Good luck.
Thank you.
All right. So, Jim, you're with Team Nightmare, and that's your robot, a veteran of BattleBots. You've been doing this for a while, you
I
said.
have been, yes.
So, you brought Nightmare out of retirement.
Yes, Nightmare's been competing since 1999. He was pretty officially retired, but I decided this was the time to bring him back out.
What's new?
Almost everything.
Yeah?
I would say probably only about 20% of the original robot is left here. Everything else is new just for this tournament. The disc is obviously the biggest change. People, the fans who know Nightmare, have always remembered Nightmare to be a big circle disc on there. I tried to keep the same style and personality, but with a twist.
What's the twist?
The twist is that it's now 1/2 inch grade 38 titanium
Titanium.
instead of aluminum.
Wow. How did you make that?
I actually had this water jet cut. It's 1/2 inch titanium cut with a high pressure jet of water.
Wow. And then functionally, though, is it running off a similar motor system?
It's the same motor system, but it's a higher voltage now.
Okay.
Changed out the entire battery system, so it's running at 54 volts now instead of 48.
So you have a lot of
little bit
power,
more speed now.
more speed. How fast does it spin up?
It spins up within a second, and it's the speed on it we're calculating somewhere over 320 miles an hour at the tips.
And then your drive system here,
It's two-wheel
Two
drive.
wheels, okay.
The back is just a caster that's freewheeling, and the two drives are able to pull the robot along.
it's upgraded, ready for action. Can't wait to see this in the
Okay.
arena. Good luck, Jim.
Yes, thank
Good
you.
luck to your team. Thanks. So I'm here with Team Rex. Well, that's your robot name, but you guys are like a mishmash of people who just love robots and got together to build this guy. All right.
Yep.
Dan, you're the captain of the team. You'll be piloting Rex. Tell me about how he operates.
So Rex operates on the principle of gyroscopic precession. What that is if you've ever seen a spinning top on a table, when it starts to tilt, it doesn't just fall over, it starts going in a circle. So what this does is the blade spins up, creates a gyroscope, and it has a big leg in the back, and when it tilts that, it tries to tilt the gyroscope, but it doesn't want to just fall straight over, it wants to turn. So that's how it makes actual steps forward. So it physically takes steps with the whole back leg.
Yeah, so one of the reasons why we went with a steel robot is there's pretty much always at events like this a welding setup that can weld steel. So we could cut off, potentially a broken or mangled piece, bend it back into place, or put on a patch panel and weld it in place. And that can be accomplished very quickly. The other way to go would be like a bolted together frame, but I just don't feel like that's as strong, and there are some other big disadvantages too.
Ryan, you're taking into considerations the tools you have here, what the resource is going to be, and then designing this robot. It's a really unique design, and I can't wait to see it. All right, thanks so much. Good luck, guys. All right, thanks. Some of these robots look really insane. So much destructive power, flames, metal, titanium. I can't wait to see that in action. Check it out on ABC June 21st. We'll see you later.